Thank you for the organizers to invite me to present the paper. It's a very good opportunity. This work is joint work with George Sandonis, also at Universidad de Alicante. So the starting point of the paper is to realize that in most patent licensing papers, it's assumed that firms operate at constant marginal cost. So, looking at that, we came up with the idea to what will happen if firms have non-constant marginal cost. Unfortunately to us, we're not the first ones to think on this idea, and there are many papers, there are some papers, some workshop participants that elaborate on this issue to see what happens if firms have non-constant marginal cost. I see here the papers. So some papers have relaxed this assumption by introducing non-constant returns in licensing models. The most related papers to ours is the one from Arigid, 2014, that considers that firms produce with increasing linear marginal cost and deals with the case of a drastic process innovations. Considering auction plus royalty licensing, he obtains that technology is licensed to all firms, both for the cases of an outsider and insider innovator. So we have full diffusion of the technology with increasing linear marginal cost. Perhaps the paper most close to ours is the one from the Bratilla and Georgios, 2009, that they consider two firms that operate with linear marginal cost that may be decreasing or increasing. And there is an external patentee that has an innovation that reduces the intercept of marginal cost and uses two-part tariff licensing contracts. And the result is very sensitive to whether marginal costs are increasing or decreasing. With increasing marginal cost, we have duopoly and our royalties used. With increasing marginal cost, you want that everybody produces because this minimizes cost, but to avoid competition among them, you impose a royalty. But with decreasing marginal cost, with enough decreasing marginal cost, I must say, we have a monopoly. You want to concentrate the production, and then you have no interest in imposing a royalty. In this paper, we focus on the case of increasing linear marginal cost. So we consider increasing linear marginal cost. And the innovation also reduces each intercept, as in the case of Georgios and the Bratilla. The difference is that we consider an internal patentee and restrict attention to two simple licensing policies, either a fixed fee or a royalty. So it's very simple. And we show the following, that a royalty contract is chosen if the marginal cost is not very steep. And the result generalizes the one in 1998 for the case of constant marginal cost. But if the marginal cost is steep enough, the patentee uses a royalty contract in equilibrium only for small enough innovations. So only for small enough innovations, you use royalty. If the marginal cost is steep enough, that is to say, we are far from the case of constant marginal cost. The main contribution of the paper is when we began to work on and trying to get results, we realized that the thing was just like a déjà vu, in the sense that the results were very similar to the ones obtained with product differentiation and constant marginal cost. And this is what we are going to show now. the close relationship between these results obtained with linear demand and homogeneous products and linear increasing marginal cost, with the results obtained with product differentiation and constant marginal cost. For this, we operate on the profits, and we go from a setting with homogeneous products and increasing marginal cost to a setting with product differentiation and constant marginal cost. To make the following operations. First of all, we write our profits in our model, can be written in this way. Demand is linear, this is the revenue, this is the price, and this is the revenues, and this is the cost. That is linear increasing in Q. So then what we have to do is to manipulate this expression, to introduce the F into this bracket, and we get this expression. I have only introduced this FQI squared in the expression of the price, and we get the result. And we take as a common factor 1 plus F, and thus we get this expression for the profits. And this, at the beginning, was a profit with homogeneous goods and linear increase in marginal cost. And we get here a profit function that is a model of product differentiation with constant marginal cost. And substitution coefficient D equal 1/1 plus F. So basically, the results we obtain with product differentiation are the same as the ones obtained with homogeneous product and linear marginal cost, once we take the relationship between the substitution coefficient and the factor of the linear increasing marginal cost. This is, you can see it in Vives 2002, this equivalence between a model with homogeneous product and linear marginal cost and a model of product differentiation and constant marginal cost. So to see the relationship, we consider and reconsider what Wong studied in 2002. In 2002, Wong compares the performance of fixed fee licensing and royalty licensing in a Cournot duopoly, where one of the firms owns an innovation that reduces the intercept of the marginal cost. So the marginal cost is constant. So if the licensor has cost C minus epsilon. What are the distinctive assumptions between our model and Wong 2002? Is that he differentiates the goods with inverse demands of this type, with this is substitution coefficient, and firms produced with constant marginal cost. Interestingly, we showed that we can replicate the results in Wong with our model just replacing F with 1/D minus 1. This expression is simply solving for F in this expression. So we replicate exactly the results by substituting F with 1/D plus minus 1. In doing the comparison between our model and Wong 2002, we realize, I think, that there is a flaw in the proof of proposition 3 in Wong, and then once corrected, the region where fixed fee licensing is superior to royalty licensing is enlarged. This is a byproduct of the comparison. But the important thing is that we can replicate the results in Wong, just replacing F with 1/D minus 1. I proceed with the model with more clarity. We have two Cournot duopolies, firm 1 and firm 2, then compete in a homogeneous good market with inverse demand A minus Q. So inverse demand is typical linear demand. A firm 1 owns a patented superior technology that allows to produce the good with a quadratic cost C minus epsilon Q1 plus FQA squared. Whereas firm 2 produces with cost CQ2 plus FQ2 squared, where A is greater than C and C is greater than E is greater than 0. And F is greater than 0, so we have increasing marginal cost, linear increasing marginal cost. So here we have that the innovation reduces the intercept, the marginal cost when production is 0. Firm 1 has to decide whether to license its superior technology to firm 2. The licensing mechanism available are fixed fee licensing and royalty licensing. So we only consider, like 2002, to compare the results, the possibility of using a fixed fee or a royalty in the licensing contract. And we study the following three-stage game. In the first stage, firm 1 sets a fixed fee or a royalty rate, so chooses a fixed fee or a royalty rate. In a stage 2, firm 2 decides whether to accept the licensing contract.
You allow both? It's a two-part tariff or either?
No. You can use a fixed fee or a royalty rate.
But not both?
Not both altogether. You have to choose between a fixed fee, to set a fixed fee, or a royalty rate. In the third stage, both firms compete at Cournot with the cost inherited from the licensing stage, and we will look for the subgame perfect Nash equilibrium using Vanguard induction. First, we compare fixed fee licensing. When fixed fee licensing is profitable, and we'll study then later on the optimal royalty, and we'll compare the licensing revenues of fixed fee with the licensing revenues with royalty. So we get, under fixed fee licensing, firm will license both non-drastic and drastic innovations if F is higher than 0.2. So if when decreasing returns are important enough, F is big enough, so we are in the case where decreasing returns are important enough. The cost savings associated with fixed fee licensing, that is to say, to share the co-production in two firms, is so important that it suffices to explain its profitability, regardless of the size of the innovation. So if F is big, fixed fee licensing is always profitable, because it's good to have two firms producing, because marginal costs are quite increasing. If F is low, we obtain the same result we obtain it with constant marginal cost. That firm 1 will only license not drastic innovations that are not very important. There's the same idea we have with constant returns to scale. If epsilon is very big, licensing technology increases much competition and reduces industry profits, and fixed fee licensing is not profitable. So it's only profitable if the innovation is small. If the innovation is small, you get the advantage of reducing cost, and you don't increase competition much, so industry profits increase, and in this case, fixed fee licensing is profitable. So when decreasing returns are not so important, however, F is small, the cost savings produced by fixed fee licensing have to be compared with its negative effect on competition, which increases with the size of the innovation. As a result of the comparison, we get that only for a small enough innovation, the efficient effect dominates, making fixed fee licensing profitable. That's the same idea we have with constant returns to scale. Only is profitable if the innovation is not very important. If it is very important, competition increases too much and industry profits decreases, so that fixed fee licensing is not profitable. We have studied fixed fee licensing, and we study now royalty licensing. Now, first of all, we studied the relationship between our model and one, that is the main purpose of the paper, to show that we can replicate the results in one by simply substituting f with 1 over d minus 1. If we substitute f with 1 over d minus 1, condition f is bigger than 0.2, turns out to be del d lower than 0.8, which is the cutoff value for the substitution parameter in proposition 1 in 1. This is the case where the fixed fee licensing is always profitable in 1. And the cutoff of epsilon, if you use this relationship between f and d, becomes this expression which coincides with condition 12 in proposition 1 in 1. So proposition 1 in our setting, with homogeneous product and increasing marginal cost, replicates the result in proposition 1 in 1 2002, in a setting with product differentiation and cost and marginal cost. So we can import the result in 1 to obtain the result obtained with homogeneous goods and constant and increasing linear marginal cost. So we have studied fixed fee licensing. So we study royalty licensing. Royalty licensing, first of all, we study the optimal royalty. The optimal royalty is R star, that is what we'll call equation 1, that is a function of E and F. Only if epsilon is higher than a cutoff value E hat, where E hat is this expression. That is condition 2. This is similar to what happens.
Can I ask you something?
Yes, of course.
Do you have any result on whether R star is monotonic in F in some way, or do you know?
We haven't tried. I don't know. Your intuition would be that R should be increasing in F. We haven't tried, but it's very easy because this expression depends only on F, so we can plot it very easily. But we haven't checked. We haven't checked. And the important thing, and for obvious reasons, royalty licensing is always profitable, except when F is equal to 0. When constant marginal cost is constant, we don't gain anything by licensing, so we don't license, and you produce by your own. But if F is different than 0, royalty licensing is always profitable. The idea is that you can set R equal to E to the reduction in cost. And in this sense, what you obtain is that competition doesn't change. So you obtain the same profits without licensing, but you obtain the licensing revenues. So when F is different than 0, royalties licensing is profitable, because you can set the royalty equal to E and you don't change the competition, and you can obtain the licensing revenues. And what I do in the next slide is to compare the results with the 1 in 1, and we can replicate them. We can obtain the results, the same results here. We can obtain the results in 1 by simply substituting F with 1 over D minus 1. This condition 1 is the royalty, condition 2 is the condition such that the royalty is R star, is the unconstrained royalty. Again, if f is equal to 1 over v minus 1, the reality rate turns out to be optimal reality in equation 20 in 2002. And 2, the condition such that we have the unconstrained reality coincides with condition 19 in 2002. And now what we do, once we have analyzed the case of fixed field licensing and royalty licensing, we compare which is more profitable, if royalty licensing or fixed fee. And then we solve for the first stage of the game that consists in deciding whether to license the technology with fixed fee licensing or with royalty. We know that he will license the technology because royalty licensing is always profitable. And this is the result. Two threshold values for the size of the innovation exist, such that if F is big, royalty licensing is superior to fixed fee licensing for field 1 if epsilon is lower than epsilon 1, and fixed fee licensing dominates otherwise. For intermediate values of F, royalty licensing is superior to fixed fee licensing for field 1 if epsilon is lower than epsilon 2, and fixed fee licensing dominates otherwise. So when F is big enough, bigger than 0.26, royalty licensing is superior if the innovation is small enough.
Let me ask you a question. If F is very large,
If
F is very large, you want to, I mean, and you have, you reduce the margin, the C, yes? The coefficient of the linear cost, not the quadratic cost, okay? In which case you want actually the firm to produce very little, okay? Otherwise, I mean, the cost is very large, and therefore it should be that you charge a royalty that makes it probably the monopoly, the optimal royalty for monopoly, or very close to that.
No, but if F is
Can
very
you
large,
go back a little bit? Huh?
if F is very large,
if F is very large,
you want
so
to
the
share the production.
epsilon affects the linear part, not the quadratic part of the cost. Therefore, you want to get rid of the quadratic, in which case you want the quantity to be very small. In order to make the quantity very small, you have to be very close to the monopoly quantity, which is the smallest. Can you go back just to check if this is, my intuition is correct? Just go 2 slides ago, before. More? Yeah, here. So if F is very large on 2, then you get actually that if, so you get that epsilon hat is A minus C. So epsilon is greater, almost that. Epsilon is greater to A minus C means drastic innovation. In which case you charge, you charge A minus C plus epsilon over 2. I think that's the optimal one, R star, to get it. Which is, let me just check, 2 times 2 times 2, 8. And here we have another 8. Yeah. So my intuition is correct. Okay, thank you. I mean, if you have, forget about the quadratic part. If in a monopoly, in a drastic innovation with no quadratic cost, just the linear part, R star is A minus C plus epsilon over 2. And that's exactly what happened when F goes to infinity, in your case. And similarly, I mean, for 2. So that's, I mean, the intuition is correct. You have to, you want to make sure that you reduce the quantity so that the quadratic part with very, very high F is not very effective. I mean, less effective. Okay.
I see. Thank you. And then, and if f is quite enough, we have that reality dominates if epsilon is small enough. But if the f is low enough, reality licensing is superior to fixed fee licensing for firm 1. This replicates the result obtained with constant marginal cost when f is equal to 0. So when f is low, we are back to a result of 1,998. So here, notice that when f is low, we are back to a result in 1, showing that under constant marginal cost, reality licensing is superior to fixed fee licensing. However, if repeating returns are important enough, when f is high enough, we obtain the clear-cut result that reality licensing is superior to fixed fee licensing only for small enough innovations. And now we see the pros and cons of royalties and fixed fee. The pros of royalties that protects films' profits by limiting competition. And the cons is that due to the fact that the royalty, the marginal cost is increasing, cost minimization requires that the total output is split between the two firms. But with royalty licensing, firm 1, the licensor, ends up producing more than firm 2. So cost efficiency favors fixed fee. The competition effect favors royalty licensing. It turns out that the positive effect on profits dominates the negative effect on cost only when the innovation is small. That is the result we obtain. And this is exactly the problem with one, that we think that there is a mistake in the proof. That once corrected, we enlarge the region where fixed fee licensing is superior to royalty licensing. So far, we have studied the case where the innovation reduced the intersect of the marginal cost, and we tried to sketch what will happen if the innovation reduces the slope of the marginal cost. So to say the patentee firm 1 has total cost given by FQ1 square and firm 2 by DQ1 square, where D is greater than F. So the innovation in this case reduces the slope of the marginal cost. Again, as before, firm 1 has to decide whether to license superior technology to firm 2. And in this formulation, if firm 1 sets the monopoly price, firm 2 would always respond with a positive output because its marginal cost is 0 when its output is 0, regardless of the value of D. So in other words, no innovation is drastic in this scenario, regardless of D. Because given that the marginal cost at 0 is 0 independently of D, firm 2 wants to produce independent of the price set by firm 1. However, we can approximate the drastic case in the limit when parameter D tends to infinity. That is similar to what you suggested before, to make F very big.
Why don't you add a small linear term like last time to resolve this issue? You can like have a common linear term for both of them, like C.
To put the two models together.
Yes, CQ plus FQ square and CQ plus DQ square. So you can have the same linear term in both. Then I don't think you will have this problem, maybe.
If I put CQ plus,
yes.
I add a marginal cost at 0 at C, no? But equal for both firms.
Yes.
I think that the monopoly price will always be higher than C. I don't know. I have to check. But to simplify things, we have considered that marginal cost at 0 is 0. The thing is that the analysis gets complicated basically because when computing the optimal royalty, the licensee accepts the royalty contract if the profits he gets under royalty licensing are higher than his profits under no licensing, as usual. This condition collapses to R lower than epsilon when the innovation reduces to the intercept. This is what we have studied before. When the innovation affects the slope, however, the condition becomes more complicated. R should be lower than this ugly expression on F. That's why we cannot obtain results, general results, but we have to obtain results for particular values of F. That's what we do next. So we consider 3 cases. The case where F is.
By the way, is the right hand side of the previous one is always positive?
I think so, but I don't know. I think so. Because
okay, sorry.
No. When the innovation affects the slope, it becomes more complicated. You
For
have
large F it is.
You have to consider the case. R cannot be very big, but if R is 0, you always want to license. So I think this expression should be higher than 0.
Okay.
So we consider 3 cases: F equal to 0, that is the patentee produces with constant marginal cost as in 1, 1998. The case where F is equal to 1, to be able to derive explicit conditions and to be able to plot the expressions. And the drastic case, which is approximated when that tends to infinity. When that tends to infinity, basically, firm 2, if it does not get the new technology, produces 0. So we obtain in all 3 cases, royalty licensing is profitable. We can check. So then we compare.
Can I ask you something?
Yeah, of course.
Here, do you have like any problem with the existence of the Cournot equilibrium? Maybe you need conditions on F also, because it's not like equilibrium may not exist given that it is, or its existence is fine, there is no problem.
I think that there is no problem with existence.
There is no problem.
Demand is linear and marginal cost is linear. I think that the normal conditions are satisfied. In all 3 cases, royalty licensing is profitable. So we have to compare the profits of fixed fee licensing with the profits with royalty licensing. And we find the following. In case 1, in case I, when F is equal to 0, royalty licensing is always superior to fixed fee licensing as in 1998. So we obtain the same result than in 1. That royalty licensing is always superior, independent of the value of D. In case 2, when F is equal to 1, fixed fee licensing is superior to royalty if the innovation is important enough. If the licensor is inefficient enough. And finally, in case 3, because that is the drastic case, fixed fee licensing is superior to royalty licensing if F is big enough. Again, if f is big enough, you want to license with fixed fee to reduce the cost of producing a certain amount, because it's better to produce with 2 firms than with only 1 firm, the total production. So these are the results we obtain when the innovation affects the slope of the marginal cost. So to conclude, in this paper, we have taken up the classical question in the patent licensing literature of the relative performance of royalties and fixed fees in a new setting where firms' marginal costs are increasing. The main message of the paper is the close relationship that exists between our model and the one-in-one, where firms sell differentiated products with constant marginal cost. So the model with homogeneous goods and linear marginal cost is equivalent to a model with product differentiation and constant marginal cost. This might open up the possibility of importing other results from the patent licensing literature with differentiated goods and constant marginal cost to our setting with homogeneous goods and increasing marginal cost. So that's all. Thank you for your attention.
Thank you, Ramon. We have a few minutes for questions, if there are any, or comments, or whatever. How difficult it is to analyze, let's say, if we have not duopoly, but rather oligopoly?
I think it's quite difficult because we have to consider that you may license not to all firms.
Correct.
So I think that this makes the thing complicated.
But I think that you can somehow characterize, even not somehow when you sell it, just either you don't license or license it only to one firm, depending on the saving of margin, reducing of the marginal cost or something like this. But so I don't know if one can expect some general results. Let's say you don't even talk about quadratic. You have a cost function and you reduce the general one. Let's say marginal cost is increasing and you reduce the marginal cost by some function, which maybe you need to assume if it's concave, convex, I don't know, but you reduce it or even linear. And the question is, for instance, about diffusion. I think it's a very important topic about diffusion of the innovation, namely to how many firms you license your technology, which benefits consumers. And so I don't know, maybe you can say something about it.
I see.
The diffusion is minimal or diffusion is maximal. Whatever.
With fixed fee licensing.
Pardon me?
With fixed fee licensing, you mean?
Yeah.
Definitely, would be very, very, very interesting. I don't know if it's easy, but I would be very interested.
No.
Because with increasing marginal cost, even drastic innovations are licensed, which does not happen, right? That was one of your. Even the drastic innovations are licensed.
Yes.
So, because it is decreasing returns, maybe there can be incentive to give the license to many, because then each one of them will be relatively more efficient.
Exactly.
Mm-hmm. You're right. So you have the tendency to want to license to many firms. As many firms as possible.
Yes.
To reduce the cost, the total cost of producing a certain amount.
Yes.
So it's possible that it could be possible to obtain the result that with increasing marginal cost, you have the tendency to sell to many firms to reduce the total cost.
Yes, and then you can collect back using a fee maybe, but then you need both of them.
But if you reduce the marginal cost so that the new cost function is, let's say, the marginal costs are decreasing, okay, then you may have only one. So it really depends on the shape, I think, of the innovation, by how much of the shape of the function that.
I see. Depends on the slope of the marginal cost.
Exactly, and the innovation, the slope of the innovation of the, by how you reduce it
You
by some
decrease the
function.
innovation.
You reduce it by some function. You may get as a result of it, even if you start with increasing marginal cost, you may end up with decreasing marginal cost as a result, or still increasing, in which case you may get, I think you may shed a light about diffusion.
I see. But it has to do with your paper, Verapilla, no? That you, with decreasing, you only sell to one firm with decreasing marginal cost.
Yeah. I think that if you have,
yeah, also I think if I can just add to this discussion, probably you may want to, bring that the two-part tariff instrument, in this case to extract, more when there is a decrease in returns to scale technology. So probably that will make the model, more effective.
But Ramon says that the two-part tariff is much more, even in his specific case.
Yes,
it's very difficult. But
no, but I think that if the correspondence between the model with homogeneous products and increasing linear marginal cost is equivalent to product differentiation.
Yeah, that's interesting.
Plus the marginal cost.
Mm-hmm. Yeah.
We have the idea that we know exactly what happens with product
yeah.
differentiation and marginal cost, that you want to sell to everybody. So I will have the result, the same result that you will sell to everybody. But this is the result in Arigit, by the way, no?
Yeah, I have a paper in Journal of Economics where exactly that two-part tariff I have considered, but with a product innovation. So basically, you sell it to potential innovators, potential licensees. And I consider two cases. One is that like you sell and you are an outsider, and you sell and you compete. And so that could be solved. And what result I got that you sell it to all potential licenses because you want to economize on that convex cost side.
I see.
And so that was a two-part tariff. That was a two-part tariff case.
So with two-part tariff, you think that you will get that you sell to everybody?
Yeah, because basically what you are doing, you are controlling the competition through R, and then you are actually dividing the output to multiple plants to just save on the cost side.
Okay, I see. We can check. So we can.
So it's published in Journal of Economics in 2014.
Yeah,
I read the paper.
Yeah, so that happened. Yeah.
Yeah. Okay.
Okay, I think that let's break for 15 minutes for the last talk today, and we'll see you soon in 15 minutes. If anyone wants to stay and to talk to Ramon, please do.
Okay, thank you.
Thank you so much, Ramon.
Tarun.
Yes.
Hi. Hello, Tarun. Are you? Yeah. Okay. Yeah. Actually, I was thinking about your paper. Do you know there is a paper by Matsushima in Economics Letters, and then I actually extended that with product differentiation. It also has some flavor of your paper. It is a completely different context. What they have done, they basically analyzed whether entry of a new firm can increase the profit of an existing firm. So you can basically think that, okay, I am an existing firm and I am actually license my technology to create an entry. And they basically, so it fits very well with your free license, because so suppose I am existing firm incumbent and I am giving you the technology freely and you enter, and now after entry actually it increases my profit.
Because of licensing?
Sure.
Because of licensing.
I see.
So basically what is happening, they don't call it license or anything. So basically they call it like this, whether entry can make some incumbents better off. So that's the way it is written. So but you can also think it's basically this entry could be an outcome of technology transfer. So I am the incumbent, I am giving you the technology, and then you enter. So I give you my technology freely to you. And once you enter, it actually increases my profit. And what happened there, that is in a vertical structure. So the difference between your paper and that paper is that the incumbent, who is licensor, is not selling the technology, not selling the input, but both firms are buying input from someone else. And now the entry can actually affect the input price and can actually make the incumbent better off after entry. So that paper has some relation with your mechanism, might be.
I see. It's economics letters, which year? Do you remember?
Yeah. Let me find it out. I have it. Yeah,
This
is a paper by Matsushima. Okay, this is a paper by Matsushima in 2006. Okay. Now there is
and your paper.
Yeah, my paper is 2019. The difference between that 2019. Same economics letters.
2019.
Now the difference between these two is that Matsushima was considering a homogeneous product, and he was showing that if entry occurs.
What are the source of increasing profit of the income?
Yeah, that's what I'm saying. So Matsushima was saying that if entry occurs, then it can actually create free entry in the input market, and that can reduce the input price to increase the industry profit. So Matsushima has a result with industry profit. He could not find the individual firm's profit. What I did, I extended that with product differentiation, and then I could show that if the products are sufficiently differentiated, then it can actually increase the individual profit also.
Very good. But that's very
so basically what is happening in my paper, that if suppose I give the technology to Torun and Torun enters, then it actually bring more entry in the input market, and in the input price will fall. And because our products are very much differentiated, think about that, almost isolated products, then actually I get the benefit of that lower input price, but not losing my profit much because the products are so differentiated.
But even in this context, if you allow the licensor to charge a fee, whatever before fee or fixed fee or royalty, can it not occur? So whether why I'm asking.
No, what I'm saying that the structure is slightly different in the sense, in my paper and Matsushima's paper, we both buy inputs from an outside input supplier.
Right.
So it is a complete. So basically, I completely freely give you, and then the input price effect is happening, and then I benefit.
But
yours is slightly different because you do not have any free entry. No. Because we have the free entry. We record the free entry. You do not have that thing, but you are actually getting some benefit from input selling. So what I'm trying to say, so both have this input market effect.
That's right.
In our case, it is creating more competition in the input market and reducing input price. And in your case, there is no competition change in the input market, but you are getting some more revenue from the input sale.
But I'm saying that, but that does not explain that whether free licensing can be the optimal.
No. It is not. It is not.
That is not.
No. I'm not going into the optimality. I'm saying that
Right.
free licensing can be profitable.
Yes, that's right.
So I
That's
sorry, I missed something which sounded very interesting. If I'm the incumbent and somebody else
Yep.
enters the market and we both demand inputs, why does that benefit
Yeah.
the incumbent? How does the
It will affect the input market.
What is happening?
It will affect the input market.
Yeah, but
It will
What is
cause
happening?
competition.
if demand goes up, the prices of the input should rise, one would think.
Because there is a free entry
No.
possibility.
What is happening like this? It is a successive oligopoly model. So when the more farms are in the downstream, that creates more demand for input,
Yes.
and as a result,
Entry-
more farms
more entry
enter
users.
the input market.
That's
And
right. That is what I'm saying.
That increased competition in the input market reduces the input price.
Yes, that's what I'm saying.
I see. So it depends on a lot of free entry in the input market, producers.
Yeah. Yes, exactly. So that's why input market entry is important for that result.
Yeah.
Okay.
The one paper I mentioned earlier, Boyvid and Langinier, they talk about that when new farms, I mean, when you're giving license to other farm, basically there is a demand shift effect because that benefits the government.
I see. Okay.
Right.
I'm getting some picture.
Yeah.
Yeah. So basically, I was thinking about your paper, Tarun. Then I thought that perhaps it has that input market link is there, but in a different
Yes.
way.
Different way, yeah. That's right.
And the point I was actually thinking, yes, I got confused with one thing about at that time when I was discussing earlier. I got confused with individual profit and the industry profit. But then I thought, and actually, I don't know, it might be that I was talking about then that when we talk about the individual profit, industry profit, then of course this issue of socially beneficial licensing, privately beneficial licensing, compulsory
Yeah.
licensing, all these things might actually come into the model.
Yeah, many things should come. Yeah, this is should come then.
Yeah. So I got confused with that individual and industry profit. But even if we consider industry profit, then all these things, policy implications might be there. Yeah.
That's right. But I like very much Ramon's paper when you have established the link between 2002 with increasing marginal cost. That I like very much.
Yeah.
Ramon. So if possible, Ramon, will you please send that paper?
Sorry?
Your paper,
Yes.
I liked it very much in the sense that when you're linking your 2002 with your increasing marginal costs with homogeneous goods. So if possible, please send the paper.
I didn't get it. Please send the paper.
Yeah. I'm requesting a paper.
Okay. Yes. No. I think you can apply it also to other settings, no?
No, the question is, can you post your paper
Yeah.
so that we can see it? Maybe you can give it to we can put it on our website. Is your paper
That's
written?
right. Yes.
Ah.
That's the way.
But
Yes, that we can do. That we can do.
Yes. Okay. That's it.
So I send it to.
If you send it to the organizers, I think we can just post it on our website, like we have been.
That will be very nice. Okay.
That will be good.
That way it gets anybody can access it.
Yeah.
If you are ready to post it.
Yeah.
No, of course I will very glad to do it.
That will be
Sure.
good.
I suggest that for everybody, in general.
Mhm.
If
Yeah,
your
yeah, sure.
paper is written, a good idea would be to send it, and we'll make sure
Sure.
it is posted. on our
Yeah.
website.
Sure.
Thank you.
I have that, we just mentioned that about my Journal of Economics paper about that convex cost. I think Devoprio and Stamatopoulos also have a paper in European Journal of Operation Research in around 2016, I guess, also that non-linear cost and licensing.
Yes, that are neither linear nor they're not
Yeah.
linear. Yes,
Yeah,
yes.
non-linear, yeah.
They consider general cost.
Yes, exactly, yeah. So I had only that convex cost, that rising marginal cost, and that I think they have that more general cost.
Yes, yes, you're right.
Actually,
You're right.
since I am one of the authors of that paper, we have a sub-additive cost function and
Yeah.
super additive, something like convex and concave, but a bit more general.
Exactly, yeah.
Very good.
Right.